Welcome back to Mr. P Helps with Algebra 2. This is Unit 2, Topic 1, SLT1E. This is where we're going to talk about graphing to solve quadratic equations. We're going to start by doing some factoring each completely. Alright, so I'm going to use the box method to factor this. So I'm going to put the first term in the upper left-hand box, last term in the bottom right-hand box. Now, 3 times negative 5 is negative 15. I'm looking for what are the factors of 15 that also equal negative 2. So it looks like it's this one, and it looks like it's got to be negative 5x. So I'm going to put negative 5x in this box and positive 3x in this box. Doesn't matter. You could have flipped those around. It wouldn't have mattered. GCF here. Okay, I put x, but actually I meant to put p. So this is just the letter p. Going up, it would be 3p. Going up would be 5, and these can both be divided by 1. So there's your answer. 3p minus 5 times p plus 1. All right, and this one, so 2 times negative 9 is negative 18. Factors that give me 18 are here, and which one of these is going to add up to 3? That would be 3 and 6. Keep in mind that the negative has to be the 3. All right, so I'm going to use the other method here. So, okay, I keep using x, but it's actually n. So minus 3n and positive 6n, bring down the other two terms. Split, factor out the GCF, it looks like it's n, so 2n minus 3. Over here, it would be 3 times 2n minus 3. All right, so it's n plus 3 times 2n minus 3. There's your answers. And let's get going. All right, so factoring is something that I had actually covered in another video. So it looks like we have just a review of doing all other sorts of things. So I'm going to kind of skip through that. So we want to get to graphing. So as I mentioned, I think in prior videos, that wherever a quadratic hits the x-axis is the solution. So the solution here is negative 3 and 2 because negative 3 is where it hits here and 2 is where it hits here. So there's two possible solutions. Now, will the answers always be positive? I'm sorry, will they always be integers? No, they will not. So sometimes the answers will be a decimal. And in that case, when using a graphic calculator, you have to go through this whole left bound, right bound. So there is a whole set of steps for that. So you just simply put this into your calculator, and then you can look to the graph, or you can look to the table to see if... Okay, so I just paused the video so you can see my graph. Oh, there it is. So you can kind of see what I've got. And that's what the answer is going to be. So you could see that the graph was hitting at 2, and it was also hitting at negative 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6 right there, and then the graph looks something like this. So the solutions are 2 and negative 6. Now when you go to table, you can find those answers also, and once again you can see in the table, you see how it's 2, 0, so that means anytime y is 0, so just keep scrolling down, then that's a solution. So the answer should have also been 2 and negative 6. So I'm going to scroll actually up to negative 6. And there it is. It's the very top one, negative 6, 0. All right, so you can basically do the same thing for all the rest of these. Now, when you get a question that does not have a integer as its answer, then you're going to have to press on your calculator. I know it's kind of hard for me to go through this with you. So you're going to have to calculate it. So you're going to have to press... second calculate, and you're looking for a number 2, a 0, and then it's going to ask you 3 questions: left bound, right bound, and make a guess. So you make sure you just press the left cursor button so that's on the left side of the answer, press enter. Right bound means press the right cursor button so you're on the right side of the answer, because wherever it hits the x-axis is the answer. And then press enter again for that, and then press enter again for make a guess, and it will tell you the answer. Now, hopefully, let me see if I can put this one in. I'm going to pause it again, put that in. Okay, and after I put all 3 of these in the calculator, I see that none of them have non-integral answers. They all have integers as their answers. So this one's negative 1 and negative 5. This one was 0 and negative 5. And this one only had one solution because the vertex was actually at positive 3. So all of these only had integers as their solutions. But like I said, sometimes you're going to have non-integral answers, meaning not integers, and then you just have to use the left bound, right bound for that. All right, so once again, I'm going to pause it so I can put this in, number 2. All right, and this question is perfect for what I was talking about, and I can even show you my entire table right there. So you can see at the very bottom of the table is that 4, 0 means 4 is a solution. But look between the x's of -2 and -1. You'll see that it goes from +6 to -5. So when it goes to positive to negative, then the 0 would have to be in between those two numbers. So we know the answer is between -1 and -2. So it's -1 point something. So I'm going to press second calculate. I'm going to press number 2, which is zeros. And it's going to give you something that looks like this. Okay, and then it's going to ask you about left bound, right bound. So I'm going to press the left-hand button until the tracer is on the left-hand side. And I know you can see it. See that little tracer right there? Okay, so I pressed left until that tracer was there. I press enter. And I'm now going to press the right-hand button so that now the trace is to the right-hand side. It's now right there. So this is the answer right there. So it's now on the right-hand side. I'll press enter again, and voila, it tells me the answer is, if I can see it, -1.5. The 0 is x equals -1.5. So there's my two solutions, -1.5 and +1, 2, 3, 4. There's my two answers. All right, so you would just do the same thing for all the others, and I'm glad I had an opportunity to show you how to do it when it's non-integral. And thanks again for watching. Have a great